Hello, everyone. You're watching the Asian American Herald, a new media network featuring the Asian Americans in the capital region of New York. You can also watch a recording of this show and all of our previous episodes from our Facebook page, Asian American Herald of the capital region. My name is Shruti Natanmai, and I'm a student at the Fashion Institute of Technology, writer and creative who's born and raised in the capital region. Tonight, we're honored to speak with Lili Kuo, a research scientist and community leader for the Albany chapter of the Asian Pacific Islander American Public Affairs Association. Lili, welcome to our show.
Well, thank you. Thank you for having me.
Of course. And for those of you tuning in live, please feel free to submit any questions via the chat box, and we'll be sure to address them at the end of the show if time permits. Okay, cool. So I'd like to start by asking you to take a minute to introduce yourself a little bit more and tell our viewers about your background. Where'd you grow up? What are some of your interests?
I was born and raised half of my life in Taipei, Taiwan.
Oh, wow.
Yeah, so and then after that, I went to University of Minnesota to get my PhD in microbiology, specifically in viruses. And after that, I did a fellowship at NIH, National Institutes of Health, also studying viruses. And then I came here because my husband was here at the time. And then I joined the New York State Department of Health, again, studying viruses. Actually, when I joined the Department of Health, I started studying coronaviruses. At the time, the coronavirus was just a common cold virus, which was really not exciting. But it was exciting. It was exciting for a research point of view, but not for public health. And then after 20 some years, actually, it was in 2016 during the Zika epidemic, and I moved to the arbovirus to start working on Zika virus as well as West Nile virus. That is the arbovirus lab, actually. So that's more of my professional career. When I'm not working on viruses, I like to do gardening. That's one of my favorite things to do. I like gardening. Right now, my project is trying to build a butterfly garden.
Oh, wow.
Because the butterflies, especially some of the special species, are losing their habitats. So one way to do this is to build a butterfly garden where they can rest when they migrate back to our region, and then lay their eggs and then provide food for the larvae, as well as the new butterflies to feed them before they migrate to south at the end of the fall. So that's one thing I'm doing outside of virology. And then the other thing I like to do is watching mystery series on PBS.
Okay, what kind of mysteries?
I like mysteries quite a bit.
Okay.
And I enjoy reading novels, sometimes listening to music. Yeah. Many different kinds of music. Yeah, that's what I do most of the time. And raise 2 kids.
Yeah. Well, yeah, that can't be easy. Well, it sounds like you keep yourself busy. Those all sound like very fun hobbies.
Well, that's the problem too.
Yeah, too fun. So I feel as though the job description of a virologist is fairly well known, but you said that you work in the arbovirus lab at the Department of Health. Can you explain what that entails exactly to viewers who may not know what arbovirus means?
Arbovirus actually is a short name for arthropod-borne viruses, or easier way to call this is a vector-borne viruses. For some viruses, it's defined by the transmission, the route of transmissions. Some viruses, such as polioviruses or hepatitis A virus, are transmitted by food, like contaminated foods through mouth or drinks. Other viruses can be transmitted by blood or body fluids, such as HIV or hepatitis B or C viruses. But for arbovirus, the infection is transmitted by vectors such as mosquitoes or ticks or insects. So arthropod means those insects. These viruses will be viruses like West Nile virus, Zika virus, or Japanese encephalitis virus. So, of course, the pandemic, some viruses can be transmitted by the droplets from patients coughing or sneezing, such as this coronavirus, the current pandemic. There are many things the virologist can study of any given virus. So my expertise is more in the molecular virology. So I'm more experienced on RNA viruses, which is a very unique part of whole virology group.
Okay.
I'm more specifically in establishing the genetic systems, or we call the reverse genetic system for RNA viruses, so that with the system that will allow us to study the virus in much more molecular details. Because RNA viruses are typically more challenging when it comes to generating a genetic system or molecular tools for research.
Mm-hmm.
So, like I said, I actually spent 20 years studying coronaviruses, and the questions I used to work on was how the virus replicate, make new viruses in the cells, and then how those viral proteins come together at the end of replication to produce more progeny viruses. So that's sort of fundamental questions I used to study. And then when I moved to arbovirus lab to study Zika virus during the Zika virus epidemic, my first job was actually establish a genetic system so we can study how the Zika virus is transmitted in different species of mosquitoes.
Okay. So you have a lot of experience with that, yeah.
Well, some of the experiences can be transferred from one virus to another.
Right.
Yes, true.
Right. So what attracted you to the realm of molecular virology? Like, what drew you in there? Because you said you got your undergrad in microbiology, or you got your degree in microbiology, correct?
Yeah, I have a PhD in microbiology.
From Minnesota. So what attracted you to that?
What attracted? Actually, I didn't know anything about virology until my senior year in college.
Okay.
Before that, I just kind of know I like science. I kind of good at science at the time. And I thought, but I was always also interested in other things. Mm-hmm. It was never really a defining moment. But when in my senior year in college, I was a medtech major at the time, and I needed to do a senior thesis. And I had a chance to go explore different possibilities. And there's this virology lab, and people tell me about this great teacher, but she's very strict. So everybody dreaded going to her lab. So nobody wanted to try it out. And I thought, I'll just give it a try. I went in there and I passed the first round of interview. And then we turned out to be great friends for life. Ever since, we're still great friends. And she was a great teacher, taught me a lot of things about virology. Then I thought, it wasn't really a big field at the time.
Right.
But it was certainly an exciting field for me. And I thought, okay, I really need to know more about this. And I naively thought, okay, I just go to graduate school to study more. And before I knew it, I was a virologist. So yeah, that's it was never something I decided to do when I was your age.
Right. Right.
I just like it just happened along the way. And the more you go, and then you sort of learn more. And the other thing actually was a surprising turn for me was when I first came to US to Minnesota, actually wanted to study immunology and the virology, more the immunology front of the viral infection. And then I started, that was also the time when the molecular biology started to blossom. There was a lot of interesting skill set and technologies developed at the beginning of my graduate school years. And one thing leading to another, and then plus those new technology allowed us to study a lot more details and more things about the viruses, and it was an extremely powerful technology. So before I knew it, I was actually in molecular biology studying viruses. So but this is something about science. Oftentimes it's very fast paced, and then it changes a lot.
Mm-hmm.
There's always new developments in sciences, and you just always have to learn, and then you just sometimes you don't really know what can happen in your life,
Yeah.
but it happened. And I just started learning molecular biology from early years, and slowly, and I've become pretty good at what I do, at
Mm-hmm.
least decent at what I do. um, I wouldn't have imagined that I would be doing this when I first started or when I was young.
Right.
I think it's very true for or almost every single aspect of science. Um, for example, like artificial intelligence, AI is like the new frontier for all of us. But I'm
Right.
sure 10 years down the road, it will be such a common thing in our daily life. And I wouldn't be surprised something else beyond our imagination uh, will come up, will appear. So I think that's also part of the lesson I learned as a scientist is that you never stop learning.
Mm-hmm.
There's always new things coming up.
That's very true. Very true. So, what has been your role during this coronavirus outbreak? And has it differed from your usual tasks?
Oh yeah, okay, yeah, absolutely. Actually, um, I like I said, most of my work were very research based.
Mm-hmm.
So we ask questions, some very fundamental questions. Excuse me. Some very fundamental questions, which may just for our curiosity, like why do viruses do this? Why do viruses infect this kind of cells but not the other cells? Something very basic.
Mm-hmm.
So that had been always been my question. Like I said, when I was doing the Zika virus, we're trying to study several of the viral proteins produced by the virus and their impact on how the viruses are transmitted in different mosquito species, right? So that's kind of, that's not a big deal, but kind of interesting to know because there are so many different mosquito species. We don't really know which one transmit better. Will that be an impact for New York State or other states? So that was originally more very research based job. And when the COVID-19 pandemic hit New York State, actually almost the entire Department of Health jumped in to help because we just didn't realize the scale of the issue and then the challenge. So regardless, whatever we were doing, we were just jumping in whatever we can do to help the system. Some people started doing assay designs. Some people are actually doing the assays, clinical assays, with of the patient samples. My job was more, again, using my molecular biology background and my knowledge in virology to help establish a good antibody assay. So one way to do that is that we need to produce a lot of specific viral proteins for the antibody testing. We can get the protein from the virus, but that would be risky because we need a lot of it. And also, we want a safe way to produce a large quantity of specific protein to high purity. So I was designing how to produce these viral proteins by different means, about molecular biology means. And each one of us will be focusing on, we actually, some of us will take a couple different proteins. So I have one of the more challenging proteins.
Okay.
So then I just focused on working on that to produce different versions of that to make sure to see which one works best.
Right. And
Um,
those tasks must be changing every day just because, like you said, the coronavirus and the updates have been changing every day. So you must be learning new things every day.
yes, actually, yeah, that's very true because we know the basic because we know a little bit about coronavirus,
Right.
and most of coronavirus share certain things. They have similar aspect there that you can go from one to the other, but there were also new things about this virus we just didn't know. So we started with one assumption. Sometimes that gets modified as we learn more about the virus. Then we have to change our focus slightly to make it more efficient or make it better. But it's really a team effort. The other thing that challenged us most is the scale of the production.
Mm-hmm.
So before, when we do research, most of things are on the smaller scale.
Right.
You obviously you're still testing your hypothesis. You don't want to go up scales, and even with a higher scale, it's not a huge scale. Now, as you can see, the numbers of cases, it's really on a scale beyond anything we have done before. So
Mm-hmm.
we're learning to look at things in a very different way now because
Right.
it's just so much bigger than we can
Right.
imagine.
Right.
Yeah.
And you said you worked on the Zika virus. So how does this work compare to that?
Uh, well, the Zika virus, like I said, my Zika virus work is more research
Okay.
to understand better of the virus and the interaction of the virus with the host, the cells that it infect. This is much more for material support to a clinical testing.
Okay.
So it's a bit different. It's two different way of supporting the public health.
Right. Right. So how has this ongoing you talked about how the pandemic has forced you to adapt to this fast-paced nature of science and just uproot basically whatever you were doing before and in order to support the Department of Health. But how has it challenged you as a person? Has it allowed you to see a different side of your career or your line of work?
Um, I mean, the working on this project certainly changed me quite a bit. One thing for sure is the time pressure, and again the challenge, the scale of the challenge, right? So, like I mentioned earlier, when we were doing the research, we actually had time to think about the questions, the design the experiments. We can test on the smaller scale before we go forward or modify our hypothesis. For this pandemic, we're literally running against the time and the tide. So we didn't have a lot of time to really test each possibility. So we just threw all the possibilities out there. So
Right.
we do everything as much as we can. That all we really want to do. We all want to deliver our task as soon as possible because we know the time is of the essence. So it was exhausting and stressful. Um, but we all try to do putting as many hours, as much of ourselves as possible. Um, but I think the great thing is I see the teamwork of everyone here,
Right.
Regardless what their expertise is, and we just all jumping, doing whatever we're able to do. I think there's a strong sense of camaraderie in the department. That's nice to see. Sometimes research is kind of a lonely path.
Right.
You have a smaller group. So I think that in some way we work as a strong team. That was encouraging in a way. The other thing that I felt, maybe I have more empathy towards the whole situation, because I look at, it's really sobering to look at the numbers of cases, deaths every single day, which I do. Probably not healthy things to do, but I want to see if our work has been able to flatten the curve and to slow down the spread. And if not, because every day when we see this uptick of infection rate or numbers of cases, it just feel it felt this is part of my responsibilities, and I really don't want this to happen to anyone. So understandably, sometimes I get upset when I see people don't keep the physical distance or don't wear the mask in public or when there are other people, because at this point it's really not just about individuals, it's
Right.
about each one of us, all of us together. If we can do something to minimize the spread, to reduce the infection rate, we're not helping just us, we're helping everyone, our fellow global citizens, actually, in that
Right.
sense. Right. So yeah, so it changes me in terms of some perspective,
Yeah.
how I see things, how I see public health,
Right.
and how I see this pandemic affects people's life, not necessarily just scientifically, but also people's life, and then economy, and then family interactions, and mental health.
Right.
So, and I have a much more acute sense how things can change even from a small virus.
Right. Definitely. And I feel like what you said is totally correct in the sense that one person cannot carry all the weight and everyone has to do their part in order to flatten this curve. And yeah, it's definitely a team effort on part of everyone, really.
It really is everyone's responsibility now.
Yeah, yeah, definitely. So, as a virologist and but what are your thoughts on how the media has been communicating the symptoms and contagious nature of the virus? Do you feel that its impact on the human body is being adequately communicated to the general public, even those who may not have a background in science or completely understand exactly how the coronavirus targets the body?
Um, I think I think everybody agrees that some media outlets are doing a better job than the others. Uh, I always initially I felt if we can bring the facts to people, they will understand. But on the other hand, there are things people may not understand without a strong science background.
Right.
So some of the information may be lost. But the other thing is I think the fact is we're, as scientists or virologists, we're all still learning. Even I think entire healthcare profession is learning about this infection. There were so many unknowns. We know the basic, but there were also new symptoms or new cases, the unexpected situations. We're just learning as we go. Some media exaggerated more than the others. Others minimized the impact, which also bothered me. Um, I think I want to believe that all the media outlets are trying to do their job to bring the information to the public.
Right.
And so I think they have good intention, but I do hope that people understand it's sometimes we don't give us straight answer because we don't have a straight answer.
Right. Right.
And we're still trying to figure this out.
Right. So there's been a lot of speculation about a second wave come winter time or around the end of the year. So what are your thoughts about that? Do you think that's plausible? Do you think such a thing is inevitable almost?
So one reason it becomes a pandemic, this virus disease becomes a pandemic, is because the entire population on this earth have never been exposed to it. The human population have not been exposed to it. We were all considered naive, right, in terms of immune response. So that means we have no protection, no antibody against it. So regardless if someone has symptoms or not. So even though we have seen this tremendous pandemic so far, it's estimated to be less than 20% of us have been exposed to the virus.
Right. Okay.
So until there is an effective, efficacious vaccine to help us reach a herd immunity protection, we are still in the danger of getting exposed. So the second wave, so that means even though we flatten in New York State, for sure, we're flattening the curve, we're seeing the reduced infection rate, any reintroduction of single case still can spread really fast. So is it inevitable? It will take a huge containment measure to really avoid it. I think it probably will happen, but we're hoping this by then we are more prepared, that we may have effective therapeutic or treatment, that we are ready to do whatever it takes to slow down the spread. And then, so even if the second wave comes, I'm hoping it will be a smaller, milder situation
Right.
our healthcare system can handle.
Right.
So that we're continuing, like, even though the infection seem to be slowing down, and then the curve is really much smaller. We're continuing to work, so we'll be prepared for next season, regardless whether it comes or not. So for my fellow New Yorkers, I hope you will see that we are trying to get ahead of the next wave, if there is a second wave.
Right. Okay. So if there is a second wave, how do you think people can, is there even a way that people can prepare for that? Or what can the general population do to make sure that the spread of the coronavirus, should that second wave hit, is contained?
Yeah, like I said, the spread is, the transmission is always exponential. So you go from 1, then you can go to 2, 4, 8. So the best way for people until an effective vaccine is available to the general public, which will be a while, because most likely the essential workers will get the first batch of vaccines, right? So at the moment, the best we can do is slow down the spread. So to do this, it's by reducing the exposure, the possibility of exposure. And the best way is, I'm still sorry to tell you, you still have to wear your mask in public, because like I said, it doesn't take very much. It takes one exposure, and then you can have a community infection.
Right.
So you still have to keep the physical distance
Right.
because that help. We know it helps once. That's why all the healthcare first responders, healthcare workers, they all wear masks, they all wear protections because we know that that will help. People may have to make some sacrifice. I know it seems really sad that you can't just go to your most favorite restaurant to have a family meal, for a while, maybe for the next year or so. But everybody's doing this. Maybe you have to go less often. Maybe you won't be hopefully it won't be as crowded.
Mm-hmm.
But like I said, if everybody really do all these basic things, wash hands, keep clean, wear your mask, keep your distance, try to reduce the possibility of exposure or spreading it, I think we can slow down the spread and we can make the wave even smaller, so it wouldn't be a huge pandemic again.
Right.
We're doing this for not just for ourselves, it's for everyone, including especially our loved ones.
Right. I think that's a really important thing to keep in mind going forward, that it really is a team effort, and the more everyone works together, the better the outcome will be.
Yes,
Yes.
absolutely.
Yes. Okay. Well, thank you so much for speaking with me today. That was very informational, and I'm sure all our viewers appreciated it as well.
You're very welcome.
Your expertise is very much appreciated. And thank you everyone else for joining us this evening on the Asian American Herald. I am Shruti Natanmai, and our wonderful guest was Lili Kuo. The Asian American Herald is a Facebook-based news media outlet dedicated to discussing topics and building community amongst the Asian Americans in the capital region. Please send us your story ideas and look for the recording of this show on our Facebook page. Have a good evening, and thank you again.
Thank you, guys.